Hi, I'm Tim Berglund with Confluent. Welcome to Streaming Data Pipelines, Lesson 1, Introduction. Well, one might begin by asking what even is a streaming pipeline. I think that would be a fair question. Fundamentally, it's where we send data from a source to a target as the data happens in real time, as a stream. And there might be some things we do in the middle from between that source and target also. You want to contrast that with the batch world, where we would wait for some time, maybe hours or a day or something like that, before collecting a bunch of data that's sitting statically all in one place and then sending it to the target. So in a pipeline, we're doing it piece by piece as things happen. Now, there are a bunch of good reasons for wanting to do this, including you can get more accurate and more up-to-date data in the target system because you don't wait, except for how long it takes data to propagate through the pipeline. You get to react to data as it changes when it's current and relevant and probably more valuable to some business that might be operating this pipeline. It lets you scale the pieces of the processing load with a little bit more control and avoids the kinds of resource shortages that can happen when there's a huge influx of data and this big batch job that you only need the compute and the I/O every so often. You just get potentially more economical use of your computing and storage resources. In the context of Kafka, a streaming data pipeline means ingesting the data from some source system into Kafka as the data is created. It's very abstract. We'll make it more concrete as we go on, don't worry. And then streaming that data from Kafka to one or more target systems. In this example, we're offloading transactional data from a database. So stuff is happening in a business, transactions are being committed, and that's getting offloaded to an object store, maybe for some offline analytical operations to happen. Because Kafka is a distributed system, it's very scalable, it's very resilient. There's all kinds of great things happening with Kafka as a distributed log there. And by decoupling the source from the target and using Kafka as a durable log in between, there are a few pretty cool benefits. Number one, Kafka stores the data for as long as we'd like. That's configurable. I've purposely called it a log. It's not a queue. It's actually a data storage system. So if the target system goes down, then there isn't any long-term permanent impact to the pipeline. It might be bad for the target system to go down at any moment. That could have business impact. But the pipeline is okay. That data is being logged in Kafka, and as soon as the target system comes back up, it resumes and is able to catch up from right before when it went down. If the source system goes offline, the pipeline is still fine. Now, somebody might be sad, right? There might be Slack messages, there might be incident response teams getting into gear, but the pipeline is okay. That's not something anybody needs to worry about. The target doesn't even know that the source is down. It just sees that there's less traffic or no traffic. And when the source comes back online, data will start to flow again, more or less automatically. Pipelines built around Kafka can evolve gracefully, a piece at a time. Because Kafka stores data, remember, it's a log, we can send that same stored data to multiple targets independently. We can also replay the data. You can rewind to an earlier point in the log, either to backpopulate new copies of a new target system or to recover from some kind of failure. Maybe a bug was deployed in some kind of analysis being done in the target, and you want to rewind and try again. Those things are all pretty easy to do with Kafka. Pipelines aren't about just streaming data from point A to point B unmodified. Now, you can do that. It's not bad, but it's kind of entry-level pipeline use, the least value add. I mean, you could also own an iPhone and only make voice telephone calls with it. Maybe that would be something you do, and I could imagine a little piece of cardboard on a piece of tape where you could flip it open and make it feel like a flip phone. You know, you could do that. That wouldn't. I don't think anybody should judge you for that, but we can potentially grow into more. So consider a typical transactional relational database. This is an OLTP system. The data is probably normalized. It sort of ought to be. And transactions or entities or events, there's lots of different ways to think about it, but they're probably entities, right? They're stored in a table. And then reference information is in several other tables related by foreign keys. For analytics, you need to denormalize that data. You need to basically pre-join it and write that denormalized thing to a separate database so that you can say for each event or each entity or order or whatever it is, let's just say it's an order, what were the additional pieces of information about it? Who was the customer? What were the line items of the order? What was the shipping address? All these things would be denormalized. And you probably want to bring that stuff together in one way or another for analytics purposes. You want to pre-join or just denormalize. You could do that on the target system, but in practice, that's not really how it's done. It gets done in the middle, on the part of the stream. It gets done in the stream instead of as a batch process later on. It just works better to do that. And this is where the second important part of a streaming pipeline comes in. I'm kind of beating around the bush, talking about stream processing. So we're not just getting data from A to B, but we're doing computation on it in the middle. We extract it from A, do things to it to make it more valuable, and then export it, or one might say load it, into B, into the sync system. This could just be a join, like I was just talking about, a denormalizing. It could be filtering, could be deriving new values, applying calculations, aggregating, running some expensive and fancy ML model, anything that you might do in between to apply the business logic of the business to that data to drive the processes and analytics that we want to do. Using Kafka for this makes even more sense when we consider the logical evolution of computer systems. What starts as a single system may one day evolve over the months and years into a group of polyglot systems. You know it's going to happen. I mean, look at this slide. In the slides I've been showing you, there's a source system, and there's Kafka, and there's a sync, and boy, that's like living in a Star Trek episode, right? Everything is beautiful and shiny and high tech. And it doesn't stay that way. They get much more complicated. And using Kafka, you can take the same logical data, that same stuff you've extracted from the source system, and write it to different syncs and do different kinds of computation on it and create new derived versions of that stream in the middle. There's all kinds of stream processing. You want to think of them as computational options that you've got in the middle. So that wraps it up for our introduction. Next up, we're going to take a look at an exercise. And before we do that, you're going to want to sign up on Confluent Cloud. You're going to have the opportunity to work along with the things that I'm showing you in the exercises, and they're going to be happening as much as possible in Confluent Cloud. So use this link I'm showing you right here and this promo code. It'll get you $101 free of Confluent Cloud usage. Go get that stuff fired up. I do want to note, since we're using some ksqldb here, that leaving your ksqldb app up and running for a long period of time can eat into that $101. So make sure you're really sat down at a time that you can really work through all this stuff in a sitting. I think you'll learn a lot. You'll get to use cloud, and you shouldn't have to pay a dime for working through these exercises. Follow along, and we'll see what we can build. So when you get to this form, enter your name, email, and password. The email and password will be used to log into Confluent Cloud in the web UI later and from the command line, so be sure to remember these credentials. That is probably obvious, but put it in a secure password manager or however it is you keep track of your passwords in a secure way. Then click on the Start Free button and watch your inbox for a confirmation email to continue. The link in your confirmation email will lead you to the next step where you can choose your cluster type. You'll choose between a basic, standard, or dedicated cluster. The associated costs are listed for each, and the startup amount credit that we've provided here will be more than enough to cover everything you need for this course. So we're going to go with standard. Then click Begin Configuration to choose your preferred cloud provider, region, and availability zone. Again, costs will vary with those choices, but at every point, we show you what those costs are at the bottom of the screen. And we'll continue to set up billing info. Here you'll see that you'll receive some free cloud credit to get you started, like we were talking about before. And by entering the Pipelines 101 promo code that I'd mentioned, you get an extra $101 on top of the standard starting credit. And that should be more than enough to get you through the exercises. Although let me caution you, in this course we're using ksqldb, and if you leave your ksqldb application running, that can chew up your free credits. So be sure when you do this course, you do the exercises, set aside some time to be able to go through all the exercises at once. That way you won't have to pay, if you're a new cloud user, you won't have to pay for this learning that you're doing. Click Review to get one last look at the choices you've made, then launch your new cluster. So sign up, get started today. Let's apply this in an exercise.